Hey, this is Coach Bryant. We are going to do equations with graphs tonight. Now, this is the next level up. You're leveling up. We're going to look at it, interpret a graph, and to make an equation. Now, in between that, we're going to give you the steps so that you'll be successful. The trick here is to make a table from the graph, just like you did last night. Graphs are made to be visual, but tables are useful because they help us explain the pattern numerically. They're better at handling numbers. So once again, we want to predict the sequence in the fourth and fifth term. And so let's look at this table. In inches, X, this is the independent quantity. Feet, Y is the dependent quantity. If we go to 1 inch, it's at 4 feet. Okay, now the problem here is that 2 inches is cut off. We can't see exactly how many feet it is. So we almost have to say, well, it rises up 2 feet for every half inch. So we can make a prediction there that at 2 feet, it would be at 2 inches, sorry, it would be at 8 feet. We're comparing feet and inches. That's really what we're comparing. That's what's in the problem. So if we went 1 inch is 4 feet, 2 inches is 8 feet. There I go again. 3 inches then would be, what do you think? See, the difference between 1 and 4 is 3. The difference between 2 and 8 is 5. So if you're looking at it from left to right, that's not a consistent pattern. But if you look at the graph, that's a straight line. It should be a consistent pattern. However, if you look at it from the top down, you see it rises 4 from there to there, and you can make the prediction because it's straight that it's going to rise 4 each time. So it's going to be 4, 8, 12, 16, and 20. So what did we really do between our inches, X, our independent quantity, and our dependent quantity, Y? Well, whatever the inches were, if it's changing by a factor of 4, then if we take for every X, it would be 1, it would be an X times 4, or 4X equals Y. 4X is the same thing as saying X times 4. It's neater and more efficient. Now, is this an additive or a multiplicative relationship? This one's pretty obvious. It's a multiplicative relationship. Okay. And that means it could be multiplying or dividing. So here we go. How many feet would be represented by 10 inches or the 10th term? Well, if every inch to get our feet is times 4, it would be 10 times 4, or 40 feet. Okay, let's go on to the next one. Let's look at this graph. Okay, so in this graph we have the total amount earned compared to the amount earned. Now our independent quality is the amount earned, and our dependent quality is the total amount earned. It's very customary and usual for the independent quantity to be on the x-axis and the dependent quantity to be on the y-axis, but what you'll learn in the future is they can go back and forth if you know the equation. So we're write an equation that describes the relationship between amount, I'm going to write this on 2 lines, earned, and total amount earned. All right, well now we got to interpret our graph. So the amount earned, if he earned $4, the total amount is halfway between 6 and 8. So what do you think that would be? That's right, it would be 7. Now, in between 4 and 6 would be 5. Okay, so if the amount earned was 5, the total amount earned was 8. And if he earned 6, the total amount earned was halfway between 8 and 10. So what do you think that would be? That's right, 9. So what you see is a consistent pattern. There's a line here that you can imagine is there. And what we have to do now is figure out, is this additive or multiplicative? So from the input to the output, is there a constant? Does it change the same amount? So 4 to 7 is plus 3, 5 to 8 is plus 3, 6 to 9 is plus 3. So that works. Every single time you have a term in the sequence, to find the output, it is plus 3. So 7 plus 3 would be 10, and 8 plus 3 would be 11. So we've completed our table, and that helped us to generate our some ideas about what our equation would be. So since this is plus 3 for every term, we can say that it is additive. Now, what would the total amount earned be if the amount earned was $10? So to do that, we really have to have our equation. Well, in each of these, no matter what the x was, to get the y, you had to add 3. So it's simple enough to write x plus 3 equals I. So basically, in this, what we're saying is that x equals 10. So 10 plus 3 would equal 13. That would be the total amount earned, $13. Okay, moving up. Now, this is an on your own problem. And I'm going to read you this scenario, and I want you to pause it, fill in the rest of it, and then I'll give you the answer. Janine has a $10 check she received from her brother for her birthday and some money in her bank account. She has the money to make a purchase of $10 more than the amount in her bank account. Let me say that again. She has the money to make a purchase of $10 more than the amount in her bank account. The graph shows the amount in her bank account and the amount she can spend. So in step 1, you'll make a table based on interpreting the graph. In step 2, I want you to determine if you see an additive or a multiplicative relationship in the table. And in step 3, I want you to write an equation. Okay? I want you to pause the video right now and solve it, and when you've got the answer, push play. All right, and we're back. So your table should read 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Notice in this table we went horizontal instead of vertical, and you really should be able to do both, read both. So, all right, so the amount earned goes up by $10 every time, and so does the amount she can spend goes up by $10 every time. So this is a constant change of plus 10. So it's an additive relationship, and that equation would be x plus 10 equals y. All right, now all of you need to turn the page over. Now, I can't put this all on your computer screen, or I'll try, but you have 4 practice problems, and these are all due tomorrow for homework. All right, good luck tonight. Oh, and you will have an entry ticket tomorrow, so you need to be ready to trade classes and prove to us you've done your work. Have a good night. Bye.